So you're sitting at home going, what did this happen to me? Okay. All right. Yeah. Okay. So next chapter, we're going to learn how to do this problem. Okay. Calculus is running a little behind. You guys are running a little ahead. It's causing a problem with your calculus. Okay. But you'll understand the concept. The concept is this. We're going to do the chain rule backwards. Okay. We're going to chain rule backwards. Now, Colin, what's the first step of doing the chain rule backwards?
Pick a U.
Pick a U. What U would you like to pick?
X squared plus R squared.
U equals x squared plus r squared. So what we're doing right now is we're assuming that the thing that makes our problem ugly, remember that's how we did chain rules at the very beginning, what makes our problem ugly, is this thing on the bottom. The thing on the top looks like it's okay. In fact, if I want to, I can clean up by pulling out variables. K is going to be a constant. Hat boy is going to be a constant. 2 pi is going to be a constant. So really all I'm doing is integrating r over x squared plus r squared to the 3/2. I cannot do this any way you've learned because there's a plus down there and a 3/4 power. There's no way to simplify this into a polynomial, right? So Colin looked at this and said, well, that bottom part looks ugly to me. That's fair?
Yeah.
And so then Colin said, du is equal to?
X prime.
No, that's constant.
That's a constant.
Constant. It's constant distance between here and here. So that's just give me a number. So what do I get?
2x.
If it's just a number, like 7 squared,
7 squared.
and I take the derivative of it,
0.
0. That goes away and leaves 2r
Why have we been writing that as a variable?
dr. Because it's going to be a number, but it's going to be a number that's a constant. It's not going to be changing. As I integrate this, the distance between the center and this point here is not going to change. The problem is the radius side is going to change. Where that spot is changing, right? Okay, so then you write du is equal to 2r dr. So I need to make the top 2r dr.
2 back.
Okay, so I'm going to put the 2 back in. K hat boy pi integral 2r 2r dr over x squared plus r squared to the 3/2. Now, for you people playing the home game for the first time, what we're doing here is normally when you do a chain rule, you add on the 2r, right? Take the derivative and you tack it on. We're doing the integral. So we got to do it backwards. So what are we going to do that 2r? We're making it appear so we can delete it. We're literally prescribing it to be there so we can get it out of here. Okay? We have to set it up so it's ready to be deleted. So we're going to delete it. If you delete it, all you got left is integral of 1 over u to the 3/2 du, right? U being defined as the bottom. This becomes k hat boy pi u to the negative 3/2. How do I take the derivative of negative 3/2?
Raise the power by 1.
Right.
Oh, derivative?
Right. Sorry, integral. I said derivative. I meant integral.
Okay, so raise the power by 1.
Raise the power by 1.
1/2.
Divide by the power I get.
-2.
And I still got my k hat boy pi. Rewritten, I get k hat boy pi. It's still going to be -2 somewhere. Can I erase this up here in the left-hand corner? So I can stay on the board.
Yeah.
I'm going to go -2 k hat boy pi. 1 over the square root of x squared plus r squared. Right, putting the u back in. And that'll do it. Plus c, we'll assume c. There's no when your radius is 0, you have no electric field because you have no disk. Okay, and that would be your effective electric field at a distance. R. Wait. How do I still have an r in there? Oh, r would be big R. Because we're going to plug it in from 0 to r. My bad. We're going to plug it from 0 to r. R being the actual radius of the disk. Right? We haven't integrated yet. We've started to integrate. We didn't actually integrate. So you plug in the r. And I get negative 2k hat boy pi over square root of x squared plus r squared minus negative 2 pi hat boy r over the square root of x squared plus 0 squared, because we start at 0 and go to r. This cancels out, just gives me an x on it with a plus, so that ends up being your final way to calculate what a electric field caused by a disk, a distance x away with a radius r and a charge on it. Ain't that fun? That should be a 0. Top should be the same. Oh, I missed my k. My bad. Should be k there. Thank you. Okay. So again, you get that interval a little bit more later on. What's the weird step? You have to recognize that charge is equal to hat boy alpha, and you also have to deal with the fact that the area can be written as the circumference of the circle times a little bitty chunk in the up-down direction.
This is charge per area.
Hat boy is charge per area.
I'm not excited for charge per volume.
Yeah. Fortunately, we're not going to do any of that until we get to Gauss. And Gauss, it's going to be a much happier place for charge per area. Oh, yeah.
Take care of the
Gauss is an infinitely happier place once you get past a certain point.
It's going to clean this up.
Yes, but the problem is it doesn't work for disks at a distance r for the thing. If it did, we wouldn't teach this at all. I mean, honestly, I'd be like, okay, they want me to teach this, but there's zero application here.
Oh, you'll Google this.
Yeah, there's no application for this. I can show it to you, but if I can get an answer using Gauss, we would never bother with it. Just wouldn't. Okay.
No other guy came up with it. Pretty sure.
No, this is the nice way to do
I'll
it.
figure it out.
There's a worse way to do this.
There was a worse way.
Oh yeah, there's actually lots of worse ways to do this, but this is. You want to see if you got a partner today, Colin? Sorry, Colin. Colin, coming after school today?
I can't have basketball.
Solid.
You don't have a partner, Colin?
Wait, is the basketball teams playing today?
No, but we only have one practice and then a game tomorrow.
Okay,
So my coach is like really wants me.
What about boys basketball? Does she know?
solid. All right.
Really easy.
Us boys.
Well, I think we have one person going. One. It's a rough set of matches for Colin. Natalie's sick. Walker's sick. Madeline just went homesick. So we got Colin and the junior boys who are basketball players too. That didn't show up last time because they had to play basketball. Well,
Come.
you can talk to them about it. And again, don't sweat it. That's for fun. You can come next time. Yeah, no,
Wait,
no,
do you have
no
like
problem.
a trivia match?
Not really a problem at all.
So you know the same. There's
Wish I'd known I could take you in my car. You can drive yourself, man?
Hell yeah, I can drive.
Wait,
I just don't want us to end up with that single person who's
Well, if you know what? If you don't, we will just not. We'll just forfeit 3 rounds. I don't care.